Okay, today we are starting booklet number 3. So booklet number 1 was a refresher of grade 9. Booklet number 2 is bonding. And then booklet number 3 is about balancing equations and reactions. And so here we go. Man, I love all parts of this chemistry in grade 10. It is just a lot of fun. Okay, here we go. Page 2 says, a chemical reaction involves changes in the chemical composition of matter producing new substances. So remember, last year you learned that when a chemical reaction happens, the product is different than what made it up, right? So if you mix sodium, which is a metal, with chlorine gas, you get salt, right? That's a chemical reaction, okay? It's made new substances, okay? A chemical equation describes what happens in a chemical reaction. So, for example, hydrogen plus oxygen equals water, okay? So the reactants they react together. So the reactants, hydrogen reacts with oxygen to produce the product, water, okay? So everything on this side are the reactants, and everything on this side of the arrow are the products. Okay, and this arrow tells you what direction the equation can go. So this is just a one-way equation. Okay, turn the page. Sorry, something in my throat. Types of chemical equations. Okay, there are 3 types of chemical equations. The first one is a word equation. Okay, and this describes a reaction using the names of the compounds. Okay, so just like we saw on the previous page, hydrogen plus oxygen produces water. Okay, just like that. Okay, that is a word equation. The next kind is a skeleton equation. And this describes reactions using the formula of a compound. So instead of writing out the words, we use their abbreviations. Okay, so hydrogen, when it's by itself, is H2. Remember, it's one of those diatomic molecules, okay? Plus O oxygen by itself is O2. It's also one of those diatomic molecules. Remember, it's a group of 7, so we start at nitrogen. 1, 2, 3, 4, 5, 6. And hydrogen, those are all the diatomic molecules. That just means that when they're by themselves, they're never by themselves. There's always 2 of them. Okay, and it produces water. Okay, oh, look, we're going to talk about it again. When balancing equations, watch out for diatomic molecules. And if I hadn't mentioned this before, I thought I did, but if not, that's okay. Let's add it to our periodic table. Oh yeah, I did mention that. See, we put little stars next to them. Okay, so let's write those down here. Nitrogen is N2, oxygen is O2, F2, Cl2, Br2, I2, and hydrogen. Okay? Right on. And the next one, the last one, is a balanced chemical equation. okay? And this uses coefficients to balance the elements on the left and the right sides so that the atoms are neither created nor destroyed. And if you're like, Miss Labiuk, what are you talking about? Well, let's take a look here. If we take a look, we're going to call this our equal sign here. So if we take a look on the left side of the equation, how many hydrogens do we have? We have 2. How many hydrogens do we have on the right side? 2. How many oxygens do we have on the left side? 2. How many oxygens on the right side? Just 1, okay? So that's why this equation here is a skeleton equation, because the amount of atoms of each element on both sides of the equation are not balanced, okay? So a balanced equation adds coefficients in front of these so that the number of atoms on the left equals the number of atoms on the right, okay? So in this case, we would add, let's see here, we're going to add a 2 in front of H2O. That gives us 4 hydrogens and 2 oxygens, okay? So if we have 2 and we want 4, that'll also be 2, and then this will be a 1. And don't be afraid if you're like, how did you do that, Miss Labiuk? We are going to do this nice and slow, okay? This is just an example to show you what a balanced equation is, okay? So we end up with 2 oxygen atoms on each side and 4 hydrogen atoms on each side. Okay, coefficients must be placed in front of a substance to show the number or show the amount of each element that's involved. Okay, so 3 types of equations. Can we use the words? Can we write it quickly down with the symbols? And then can we actually balance it? Turn the page. Okay, sometimes when you see a balanced equation or where you see a skeleton equation, the state is also given. So it tells you if what you're working with is a solid, L for liquid, G for gas, okay, and AQ means aqueous, okay, and it's dissolved in water. So that means whatever it was added to water first, okay? So if we go back to our equation, our hydrogen plus oxygen equals water. Hydrogen is a gas, so it would be a small subscript G. Oxygen is also a gas, small subscript G. And it makes water, which is a liquid, small subscript L. Okay? Now, all atoms in the equation on the left side must equal all the atoms on the right side. And that's how you get a balanced equation. Otherwise, atoms would be created or destroyed, which cannot happen. Okay? You can't spontaneously create a substance. It has to come from something. Okay? Reactants are on the left-hand side, and we talked about this already, and products are on the right-hand side. Okay, awesome. Nice job.